Here's one solve path for today's inverse LITSO. Okay, so we are looking for a tetramino of unshaded cells in every region. Um, the easiest thing to start with is the small regions to see which cells must be part of that tetramino. We can scan around and do those pretty quickly. There are a lot of 5-cell regions in this one. So in this 5-cell region, either we got this L or we've got this L. Either way, the middle three must be part of the tetramino. You can do the same thing here and here. 2, 3, 4, 1, 2, 3, 4. So this middle dot, 1, 2, 3, 4, 1, 2, 3, 4. This one, this one. Okay, those are the super easy ones. Then we got these 5 cells that make a P. These are a little harder to look at, but you can hopefully see that no matter how you do 4 cells in them contiguously, this this cell right here is definitely going to be part of the tetramino. So we can do that in all 4 of these. Okay, so now let's get started with the real solve. Let's look first at this top right. So whichever way we extend this, it's going to be an I piece, a 4 in a row, an I. So since identical tetraminos can't touch, this next one right next to it, which must touch it, can't be an I, must be an L. So we can fill in the last space there. Now let's think about what happens if this if this piece right here is black. Now we're going to think about the logic about all the black cells must connect. So if this is black, it's got to go out this way, but you can see the problem is in order to reach anything else, it's going to have to take up 2 cells in this region, which is not allowed because it's only 5. We need 4 of them for the tetramino. So that is not black, therefore this is black, so it must go down here. Now let's look at this long region. What if the tetraminos started right up here? Then it would be 4 long and it would cut off this black area there. So it can't do that. So it must start at least here, if not farther down by that logic. Therefore, this cell right here is black. But we also have the rule that 2x2s can't all be black. So these 3 make this one unshaded. And now we have the start of our tetramino, so it has to go down these 4, and the rest of these have to be black. Okay, now continuing, we got a black region here that is cut off in every way except for this right here, so it's got to go down here at least until it meets other black cells. But it can't actually go any further because now we have the 2x2 problem. So this has to be unshaded, and now we've got the start of an L, of a tetramino, which is an L. So we've got those done, so these 3 have to be black. Now we've got a couple potential 2x2s here. We gotta fill those in. Now in this region right here, we have what will need to be the 4 cells of the tetramino there, and then we can fill in the rest. Okay, so now we've got this black area coming down here, and it must go across the bottom and keep going. So now this one is done. Got an L right there. Okay, so now let's look up here at the top. Okay, this P, what if this were black? Then the rest would be unshaded, and the black one would be stranded, so it's not black. What if this was the black one? Well, then we would have 4 cells making an L touching another L, which we can't do. So this has to be unshaded. What about if this one is black? then the black is going to have to escape, so it's got to go down here, and now we have the same problem we saw earlier, where there aren't enough cells in this region right here to be black. So that can't be right. So this has to be unshaded, leaving that as the black cell. Okay, making some progress. So how about this one? We have exactly the same problem. If this is black, it can't escape. So that is unshaded. Now this shape here, this can't be black because it wouldn't be able to escape. This can't be black because it wouldn't be able to escape. So it could be either this one or this one. And that would make the shape either an O or an S. And if it's an O, it would be next to another O. Not allowed. So it is the S. Oops. It is the S. There we go. This black must escape. So now we've got a T here, and that's done. This right here, what could that be? Well, it can't be a T now because it's next to a T. So this must be part of the shape. It can't be an L because it's next to another L. So this must be part of the shape. And this can't be black because it would have nowhere to go. So now we've got an O there. And this black region has to escape. This one has to escape. All right. We are almost done with what I would consider the straightforward parts. I'm not going to say easy, but possibly straightforward. This region is the next one to look at right here. Okay, so if our shape started there, it would be these four, and it would cut off this black area. Not possible. So this one must be black. The same thing that we saw over here. That we now have 3 out of 4, so that is part of our shape. It goes there, and it goes either that way or that way. Whichever one is the case, this is not part of it, so this one's black. And we've got an S touching it, so we can't have another S. It's got to be an L. Great. So we've got an L here. Could we start this long shape right here? No, because it would be an L, and it would touch an L. So that's definitely black. Now, this black, this is all interesting all of a sudden. This black right here, actually this comes down. This is an easier way of seeing that. Should have done that first. Okay, so this black region needs to connect to the rest of this stuff. How is it going to do that? Well, only by traveling around the outside because it's blocked by green cells through here. So we're going to have to do at least that. And now we can't have a 2 by 2, so that's unshaded. It's an I, so this one is shaded. Great. Okay, so now we got this last little bit. This is the tough part. Okay, so where could we have our remaining tetramino? Could it start in this cell at the bottom? Well, if it did, it would reach up this far, and there are only a few choices. Either it's got to go to the right, in which case it cuts this thing off, not allowed. So it must keep going up. Now if it goes to the right, it'll still cut that off, not allowed. What if it goes up? Then it cuts this left part off from the right part. Same deal if it went to the left. It would cut it off. So none of those cases work, so this one is gonna have to be shaded. As soon as we do that, we have to avoid a 2 by 2, and we have one of the cells of our tetramino. Hooray. Okay, so let's try that those cases again. Where could this grow legally? Okay, this is getting tougher. So let's say it grows to the right. If that's the case, then this black comes up here. And what could this region do? It could go straight up in one of these two ways, but it can't because this is an L. So the only other thing it could do would be an O, which seems okay except that's going to mean that the remaining cells make a 2 by 2 here. So that's not okay. So all that, what that proved was we can't go to the right. This has got to be black. This has got to continue upward. All right, so possibilities. It could go up and to one side or the other. Either way it goes, there are a few problems, but the main one is it's going to touch another L in either case. So we can't do that. So what other shapes could it make? We could make a T with it, or we could make an S with it. Suppose we made the T. Now we have cut off this big black region from the other one. Can't be a T. And in fact, actually, I should have started by saying we've proved that it can't do this because of the L's. So this is certainly a black cell. Could have done that first. So this one right here can't be a T. It would cut things off. Can't be an L because it would touch another L, among other things. So it's going to have to be the S. So it's going to go right there and right there. And where does that leave us? One more shaded cell right there.